We're given a 3 by 3 grid and we're told that it uses 24 centimeters of wire and we're asked how much for a similar 20 by 20 grid. So what I did in this question is I just counted like the number of kind of um, threes that we have like this. So 1, 2, 3, 4. This is going to be 4 lots of 3 if I said that this was a unit, for example. So 4 times 3. And then if we also do it vertically, then we also get 4 times 3. So that's going to give 24. And what that tells me is that each one of these little bits, like the length of one of the little squares, is going to be 1. If I'd got like 48, then I'd have to, then it would be 0.5 and so on. So I hope that makes sense. Now, we can sort of see that in a 3 by 3 grid, you get like an extra 1. Like you don't get 3 lots of 3, you get 4 lots of 3. So in a 20 by 20 grid, you don't want to be drawing this. I have had somebody like complete this question by drawing it. You can do that, but you don't need to. Instead, let's think about it. So we've got 20 by 20. That means that I'm going to have 21 of these, basically. These are horizontal lines because you've got 20 squares going down. So it's going to be 21 times, and then the length of it is actually going to be 20. Okay, so that's the horizontal part. And then if we do the same for the vertical part, it's going to be exactly the same. So it's actually going to be 21 times 20, and then we can times by 2. So could just do this, yeah, times by 10 to give 210. Actually, yeah, I could rearrange this to 21 times 10 times 4, which is going to be 210 times 4, and therefore I'm going to get 840. So that is a good way of doing this question. You might even want to think, how could you generalize to any n by n grid? It's quite an interesting question. And then it's going to be very, very similar, but this time we've got like this length is going to be n, but I'm going to get n plus 1 horizontal lines, each of length n. Then I'm going to get exactly the same in the vertical direction. So that's going to be my answer. Nice, nice problem.